take a look at these functions. As x approaches to positive infinity or negative infinity, what happens to sine of x, cosine of x, tangent, and inverse tangent? I built all these graphs using decimals. You can look it up on Google or download the app for free. It's DESMOS, is completely free. Okay, back to the problem. First of all, you are taking calculus right now. I expect you to be able to graph sine, cosine, tangent, cosecant, secant, and cotangent without using calculator or any graphing device. All right, so for the sine, what happened as x approaches to infinity? You look all the way to the right. What happened? You can see that the graph goes up and down between what numbers? Between positive 1 and negative 1, right? So it goes up -1 and then drops down to -1. So the graph is a curve bouncing between -1 and 1. So we say that as x approaches to positive or negative infinity, it is impossible to determine what y approaches to, because y oscillates between -1 and 1. It is bouncing between -1 and 1, so it is impossible to determine what y approaches to exactly. So therefore, we say that these two limits does not exist. So does not exist, I use D and E. Most of the textbook just call that D and E. D and E means does not exist. So what about cosine? So for cosine, same thing, similar graph, not the same graph. Similar graph, y is bouncing between -1 and 1. So we say that y oscillates between -1 and 1. So that's therefore, as x approaches to positive infinity or negative infinity, the limits does not exist. D and E does not exist. All right, so how about tangents? So for tangents, you have what do you see? You see vertical asymptotes, right? So there are many vertical asymptotes. So for when x approaches to positive or negative infinity, the tangent does not exist. So this one is also does not exist. You have the same conclusion for cosecant, secant, and cotangent. So the next one is arctangent. Arctangent is the same thing as inverse tangent, the tangent with a -1 in a corner. So arctangent, this function shows up a lot in calculus. So whenever you study limit as x approaches to infinity, the arctangent shows up a lot. It is a good problem because it has two horizontal asymptotes. Take a look. As x approaches to positive infinity, what happened? As x approaches to positive infinity, y approaches to, does not exist. This is not does not exist. As x approaches to positive infinity, this is what? Y approaches to pi over 2. So as x approaches to negative infinity, which is another limit, y approaches to negative pi over 2. Again, this function shows up a lot when you study limit at infinity. So arctangent or inverse tangent has two horizontal asymptotes, one at y equals to pi over 2, the other one at y equals to negative pi over 2. Make sure you write this down. This really shows up a lot. So before we end this video, I want to discuss two more, the exponential function and the natural logarithm. So for exponential function, e to the x power, we have the graph. So what happened as x approaches to infinity? So as x approaches to infinity, y approaches to infinity. So therefore, the limit as x approaches to infinity, e to the x, this is just e raised to a very big power, so that is called infinity. This is a right answer, but some textbook will just, especially when you do homework online, sometimes they ask you to do this. If that is infinity, they will just want you to write D and E for does not exist. But in some textbook or in some online homework system, they would like you to write down the infinity first and you say the limit does not exist. So D and E. So what happened as x approaches to negative infinity? Is that a D and E as well? The answer is no, because the e to the x has a horizontal asymptote. So has a horizontal asymptote at what? At y equals to 0, which is called the x-axis, right? So therefore, as x approaches to infinity, y approaches to 0. So therefore, the limit as x approaches to negative infinity, e to the x, so this is e to the negative infinity, right? So which is 1 divided by e to the infinity, that is 1 divided by a very large value, which is just equals to 0. So therefore, the horizontal asymptote of e to the x is y equals to 0. All right, for Lnx, do you see any horizontal asymptote? The answer is no. There is only one vertical asymptote at x equals to 0. So as x approaches to 0 from the right, y drops all the way down to negative infinity. All right, but as x approaches to infinity, y approaches to infinity. So sometimes the problem would like you to write the positive or negative infinity out, and then you say the limit does not exist. Okay, so we have the same conclusion for the common logarithm, the LOG. Because the graph, they are very similar. They are not exactly the same. They are very similar. They both have a y-intercept at 1, 0. All right, so that is the end of this video. I hope you memorize or write down the arctangent because it shows up all the time. Again, thank you for watching. I will see you all in the next one. Signing out.